combine two lessons in one. We're going to do 3.4, which is adding and subtracting with inequalities, and 3.5, which is multiplying and dividing with inequalities. Let's think about the difference between an equation and an equality. An equation is where you get a variable equals one number. There's only one solution. An equality, you're going to have a variety of numbers. So for example, here's a first inequality. X is greater than 2. Anything bigger than 2 is going to be your answer. 3, 4, 5, forever and ever it's going to go on. So this is how you would say this inequality. X is greater than 2. And this is what it looks like when it's graphed. You use a number line. When you have a greater than, it's going to be shaded to the right because you want anything bigger. And 2 is not included, so it's an open dot. Y is less than negative 5. Anything smaller than negative 5, anything to the left of 5, negative 5 is going to be your answer. So negative 6, negative 7, so on and so forth to the left. That's why it's represented by this graph. The shade region is your answer. Negative 5 is not part of your answer, so it is not shaded in. X is greater than or equal to negative 1. Because it has this equal to, it means anything negative 1 or bigger is going to be your answer. That's why here negative 1 is shaded in. X is greater than or equal to negative 1. Here's negative 1, anything bigger as well is your answer. X is less than or equal to 3. Again, because they have this equal to, 3 is an answer, or anything smaller. So it would be represented by this graph. 3 or smaller is your answer. So let's sum this up. If you have a greater than or a less than, you're going to have an open dot. If you have a greater than or equal to or a less than or equal to, you're going to have a closed dot. So let's try graphing a few. So let's start with f is greater than or equal to 2. What you're going to do is draw a number line. And that number line does not have to be big. I think one number bigger and one number lower is good enough. It'll show you your results. You have to decide if this is an open or closed dot at 2. Because there's this equal to, it's closed. And then f is greater than or equal to means we want things that are bigger than 2. Here's a trick as well. The inequality symbol will point in the direction of where you need to shade as long as the variable is first. Try t is less than 0. We draw a number line. The number line means one bigger number and one smaller number. Less than means open because 0 is not included, but we want smaller numbers. Our answer is negative 1 or smaller. Okay, let's start solving inequalities. K plus 12 is less than or equal to negative 4. You're going to solve inequalities the same way that you would solve equations. You're going to want to isolate the variable on one side of the inequality symbol. So here the k is going to stay. To do that, you're going to use the inverse operation of 12. The opposite operation of adding is subtracting. Whatever you do to one side, you do to the other. So on the left side of the inequality, I have a k. I drop the inequality symbol. Here I have same sign sum. I get negative 16. After you solve your inequality, you are going to graph it to represent your answers. So on my number line, I'm going to use the number that I got for my answer, one number higher and one number lower. My answer is less than or equal to, so it's closed, and it's less than, so I want smaller numbers. This one's going to look a little different. Negative 1 is greater than y minus 7. This time our variable's on the right side of the inequality. We still want to isolate the variable. The y is going to stay on the right side. But I need to bring this 7 to the other side. Here I have different sign difference. You're going to notice that this inequality is backwards. You have to be very careful graphing these inequalities Because when the variable is second, you have to read the inequality symbol backwards. This actually says, when you read it, y is less than 6. You would not read it this way, 6 is greater than y. You would read it backwards. This actually means y is less than 6. What I did is I reversed the order and the inequality symbol flipped. This is what I'm going to graph. One number higher, one number lower. Less than is open and means I'm going to shade to the left. You see, if you would have just left it 6 is greater than y, you probably would have went greater than and it would have been wrong. Okay, I want you to try 2 addition problems. I want you to try 10 is greater than or equal to y plus 4. And then I would like you to try x minus 9 is less than negative 6. Push pause and try those now. You're going to see on this problem right here, again, our variables on the right side. To isolate the variable, I do the opposite of adding, which is subtracting. And again, my inequality is backwards, so I need to flip that before I can graph it. This really says y is less than or equal to 6. That's what I'm going to graph. Closed at 6, less than or equal to. This one, my variable's on the left side of the equation. I'm going to bring 9 over. So I get x is less than 3. I read this normal because the variable is first. I don't have to switch anything around. X is less than 3. Open and shaded to the left. Okay. So adding and subtracting, summing that up. Adding and subtracting is the same as solving equations. There's nothing new. But multiplication and division have something new. Okay, I'm going to make a little asterisk here. When you're multiplying or dividing by a negative number, you need to switch the inequality symbol. So I'm going to say reverse inequality symbol when multiplying or dividing by a negative number. So important that I'm going to highlight it real quick. Let me give you an example of what I mean. K over negative 8 is greater than or equal to a negative 5. Our goal is still to solve for the k to isolate the variable, so we're going to use the inverse operation. On the left side here, I see that they're dividing. The opposite would be multiplication. And I need to bring that negative over. Because I'm multiplying by a negative number, that's what it says here, reverse inequality symbol when multiplying by a negative number. I'm multiplying by a negative number. That means I'm going to have to switch this inequality symbol. And so I don't forget at the end, I like to circle it. You don't have to, it's not required. But it helps me remember to go back and switch that inequality symbol. Because I'm multiplying by a negative number. Negative 5 times negative 8 is a positive 40. Just like above, you are going to graph your answers. Your number line does not have to be very complex. One number higher, one number smaller. Y is less than or equal to, close that, and we want smaller numbers. Okay, let me just give you an example when you would not switch the inequality symbol. 7s is less than negative 14. My goal is to isolate the variable, so I'm going to do the inverse operation. Opposite of multiplying is dividing. You see that I'm not bringing a negative over this time. I'm just bringing a normal number over. This is when you do not switch the symbol, it just stays. S is less than -2. Now again, think about the difference between these new things. This is when you use the new rule, the highlighted rule. When you're bringing a negative to the other side, when you're bringing a positive to the other side, everything stays the same. I would like you to try -6s is less than 54, and also try u/6 is greater than or equal to -3. Push pause and try that now. In this first example, see s by itself, they're multiplying, so I'm going to divide. I am bringing a negative over, so I need to switch that sign. S is greater than -9 is my answer. You should have graphed it to show all the possible answers. S is greater than is an open dot and shaded to the right. Over here, they're dividing, so I'm going to do the opposite and multiply. I'm not bringing a negative over, so I don't switch